Hello everyone, myself Mrs. Rama Ranjankar, lecturer in Electronics and Telecommunication Department from Praveen Patel College of Diploma Engineering and Technology, Bandra. Today I am going to explain the chapter number 5 of LIC, Specialized IC Applications Part 1. In this topic we are going to learn the timer IC 555 block diagram and pin diagram, timer modes and the timer application. So 555 timer is one of the most popular and versatile integrated circuit ever produced. So it is last 30 years old and still being used. So it is a combination of digital and analog circuits. It is known as a time machine as it performs the wide variety of timing tasks. So 555 timer operates in several modes like monostable mode, stable mode, bistable mode, also called as a Smith trigger mode. So 555 IC has a wide range of application and it can produce accurate time delays and oscillation. So in this diagram, the pin diagram of 555 IC is given. So it has a total 8 pins. So pin number 1 is connected to ground. Pin number 2 is a trigger IC. Pin number 3 is a output pin. 4 is a reset pin. 5th one is a control voltage pin. 6th is a threshold voltage pin. 7 is a discharge pin and pin number 8 is a positive supply to the IC. Around 3 volt to 18 volt power supply is to be applied here. So this is a pin description. So pin number 1 is a ground reference voltage. 2 is a trigger input. The out pin goes high and the timing in interval starts when this input falls below the 1/2 of control voltage, which is typically 1/3 VCC, control being 2/3 VCC by default if the control left is open. So in other words, output is high as long as the trigger low. So output of the timer totally depends on the amplitude of external trigger voltage applied to this pin. So negative going pulse is to be applied for the trigger input. Output, here the output shows. Reset is a timing interval. May be reset by driving its input to the ground. So, but the timing does not begin again until the reset rises above approximately 0.7 volt. So, overrides the trigger input, which overrides the threshold. Control voltage provides a control access to the internal voltage divider. Threshold, the timing interval ends when the voltage at threshold is greater than at control. Discharge, the open collector output which may discharge a capacitor between the intervals. So in phase with the output, and VCC shows the positive supply voltage which is usually between the 3 and 15 volt depending on the variation. Let's see the block diagram. So block diagram of 555 IC consists of 2 comparator, 1 flip-flop. Also consists of voltage divider, discharge transistor and output step. Voltage divider consists of 3 identical pi Q resistors which create 2 reference voltages, 1/3 VCC and 2/3 VCC of the supplied voltage, which can range from 5 to 15. Comparator is a circuit element that compares the 2 analog input voltages at its positive and negative input terminal. So if the input voltage at the positive terminal is higher than the input voltage at the negative terminal, the comparator output will be 1. If the voltages at the negative input terminal is higher than the voltage at the positive, then the comparator output will be 0. Next are the 2 comparators. The first comparator negative input terminal is connected to the 2/3 reference voltage at the voltage divider and external control pins, while the positive input terminal to the external threshold pin. On the other hand, the second comparator compares the negative input terminal which is connected to the trigger pin and the positive one is connected to the 1/3 VCC. Using these pins, trigger, threshold and control, we can control the output of through controls, so which are then fed to the R and S inputs of. So here the 555 block diagram shows. The flip-flop output 1 when the R is 0 and S is 1 and vice versa it will be 0. So then R is 1, S is 0. The flip-flop can be reset via the external pin called as a reset, which can override the 2 input, thus reset the entire timer at a time. The Q-bar output of the flip-flop goes to the output stage or the output drivers, which can either source or sink a current of 200 mA to the load. The output of the flip-flop is also connected to a transistor that connects a discharge pin to the. Let's see the application of 555 IC. So first one is a monostable multivibrator. So monostable multivibrator has a one stable state and one unstable state. The stable state can be chosen either high or low by the user. So if the stable input is high, the output of the timer is high. At the application of the interrupt, the timer turns low. Since the low state is unstable, it goes high automatically after the interrupt passes. So similarly is the case for a low stable called as a monostable multivibrator. This is a stable multivibrator. So this is called as a free running oscillator. It has stable. So the stables it does not provide any stable state. So it produces the continuously waveform. So output will be swinging between the high and low. So this character of unstable output is used a clock or square wave output for many applications. Bistable multivibrator, the circuit is called as a bistable because it has a two stable state, output high and output low. It is known as a flip-flop. So it has a two inputs. Trigger makes the output high and reset makes the output low. It does not use any RC network to provide the output waveform. So here we are using the two switches, and therefore that invert that 555 timer IC is called as a bistable multivibrator. This is a comparator comparison of multivibrator circuits. Smith trigger is one of the application of 555 IC. So in Smith trigger is called as a, here the two internal comparators are tied together and externally biased at the VCC by 2 through R1 and R2. Since the upper comparator will trip at 2 by 3 VCC and the lower comparator tripped at VCC by 3. The bias provided by the R1 and R2 is centered within these two thresholds. Voltage control oscillator is another application of 555 IC. So it is also the application of a stable multivibrator. So stable multivibrator input is applied, output is applied here so that it converts the charging and discharging waveform. Thank you.